welcome to our 9-3 video lesson. So go ahead and put up the top 9-3 factoring trinomials. Just a little bit of a heads up, this is part 1. We'll see part 2 later on, so just realize that trinomials are broken apart into 2 different lessons. And then put today's date in that top right hand corner. And of course our learning target. So the objective for today is I am learning to factor trinomials. So the key vocabulary word for today is trinomials. So just like tricycles have 3 wheels, triangles have 3 sides, trinomials have 3 terms. And they look like this right here. Ax squared plus bx plus c, in which a, b, and c are numbers. So they're your constants and your coefficients. So even though we use variables a, b, and c, just realize a, b, and c will be numbers in all the problems we do today. Next note about trinomials is that they factor into 2 binomials. And that just reminds us that bicycles have 2 wheels, so binomials have 2 terms each. Like you got parenthesis with, oh, kind of made that a little wonky. Try that again. 2 binomials. So, parenthesis with 2 terms, and then another parenthesis with 2 terms. There we go. And now, for today, we do have our steps, and as we do our steps for our x squared plus bx plus c, if you notice, a always goes in front, and this guy doesn't have the a in front, which means our a for today will always be 1. So our leading coefficient today will always be 1, which means we're just kind of looking at our basic trinomials today. And as we look at our basic trinomial, we're going to do an example of the steps out the side of it. So go ahead and write out our example. It's going to be x squared plus 13x plus 36. There we go. So our first step for our trinomials is to check for GCF. So all of factoring, we check for GCF to start with. Cool thing about today is that we said the leading coefficient will always be 1, so there's a 1 here in front. We don't have to show a GCF of 1 because we know it goes into every number. And then x squared is in my first term, x is in my second, no x's in my last, so since that last guy doesn't have an x, there's no x's in common, so no GCF. Now for this next part, I do kind of like to write my trinomial form above it, ax squared plus bx plus c, that way I can see it, and we're good. So for step 2, we are now going to find the factors of a. If you remember, a is that first guy there in front, so first term, and c. And c is the last guy out here, so it's our last term. So find our factors of a and c. We're going to do that in making a table. So just make yourself a little note that we're going to make like a little T-chart, so a T-table. So make sure you show that in your work for me. So we come out to the side here, make our T-table, and we're going to first find our factors of a. So lucky for us, a today is 1, so a is 1. And then find our factors of c, which is that last guy. So c, which is positive 36. c is positive 36. And we're good. The factors that multiply to a are 1 times 1, because 1 times 1 makes 1, and we're good. No other factors for 1. To find your factors of 36, we're just going to start dividing. It's like 36 divided by 1 is 36. So 1 times 36 is 36. 2 times 18 gives us 36, or you can do like 36 divided by 2 and get 18 in the calculator. 36 divided by 3 will give us 12, so 3 times 12 is 36. 4 can go into 36 9 times, so 4 times 9. 5 cannot go into 36 evenly, 6 can. 6 can go into 36 6 times. And because it's the same number here, that means the next factor that would work would be 6, and since I already have 6 written, we don't have to go any farther. So 6 times 6 is our last set of factors. Okay. Now, step 3. We have our factors of A and C. This is where we have to pay super close attention. So we're going to go ahead and set up the two binomials. So we already set it factors into two binomials, so we're going to set those up. Oh, there we go. My A and my L kind of joined together there. So two binomials with factors of A and the x squared, first in each. Parenthesis, and the factors of C are second. Oh, forgot the word R. Factors of C will be second in each parenthesis. There we go. Now, here's a key part of this. So we set up the two binomials. We set up two parentheses for two terms each. We're going to pull our factors in here, but here's the key part of step 3. So big star. The outside and inside products. That goes back to FOIL. So the outer and the inner. So the outside and inside products. Products just means we multiply them. That's what we do for the FOIL. Products add to B. That's the key word there. They have to add to B. And B is just our middle term there. So B's here in the middle. So B is going to be 13. So as I pull the factors, I have to make sure I pull ones that will add to 13. Now here's the cool part about today. Our factors of A, so where it says the factors of A will be first in each with the x squared, and all that means is x squared breaks apart into x and x, so I have to make sure I have x and x first in each parenthesis. So since my factors of A are 1 and 1, I'll have a 1, and because it's an x squared, x, and my other factor is 1, so 1x. So I have 1x times 1x will give me the x squared, so there's my factors of A, check. And now my factors of C. Now here's the cool part about the factors of C. Is that we can go ahead and look forward today to which ones will add to B. So it's like I could go ahead and put in there, it's positive 1 and positive 36 plus 1 plus 36. But if I were to check the outside and the inside products and do 1 times 36, so 1x times 36 is 36x, 1 times 1x is going to be 1x. Add those together, 1x plus 36x will be 37x. That is not going to give me 13. So I can go ahead and use my factors of C to kind of a little bit of common sense and see which ones should work. So we know 1 and 36, way too big, gave us 37. So if you add 2 plus 18, that gives you 20, still not the 13 I'm looking for. 3 plus 12 is 15, we're getting closer, but still not 13. 4 plus 9 does give us the 13. So we can use a little bit of common sense, or a little bit of math sense there to kind of help us from having to guess and check a lot. So it's a positive 4, so my factor of C will be positive 4, and then my other factor of C will be positive 9, so plus 9. Now the very last thing we have to do is we have to check it. So check, I like to call it the OI because we're going to check the outside and the inside to make sure it adds to B. So rather than doing the full FOIL, and we will check it with the full FOIL, all we have to do is just the outside and the inside check. So I call it the upside down rainbow. So we're going to do our 1x times 9 and get 9x. 4x times 1x is 4x. We add them together, so 4x plus 9x is 13x. That's my b here in the middle, so we're all good, so that checks. So our answer for this one is 1x plus 4 times 1x plus 9. And we're all good. Now, to do a full check, if you want to make sure your whole answer is correct, you would just take your 1x plus 4 times your 1x plus 9 and do the full FOIL. So our first terms are 1x times 1x, which gives us 1x squared. I'm not going to show the 1 this time. Outside, 1x times 9 is 9x. Inside, 4 times 1x is 4x. And then last, 4 times 9 is 36. We know in FOIL we can add those middle two together, so our x squared drops down. A positive 9x plus 4x is positive 13x plus 36. If you notice, that was the original problem we started with, x squared plus 13x plus 36, so it checks. Now, as far as it goes, we'll see some more examples, but before we do, let's write down some sign rules. This will kind of help us out in making sure we always grab the right signs. So, if you think about it, we're always going to have to find the factors, and that means the numbers that will multiply to C, which is our last terms. So if we're multiplying to C, C tells us what signs we need to use. So if C is positive, same signs. I skipped a word there when I was talking. So if C is positive, we'll have the same signs. And that's because a positive times a positive is still positive, and a negative times a negative is positive. So negative times a negative makes a positive. By the opposite thing, if C is negative, then we'll have different signs. That means we'll have one has to be a positive times the other one has to be a negative in order for you to get a negative. Or vice versa. A negative times a positive gives you a negative. So just a little bit of sign rules there. And now let's see how this all applies to our first example. Okay, so for our examples, example 1 here, we have n squared minus 13n plus 42. So step 1 for all the factoring is to check for GCF first, and because I have a 1n squared here, 1, we don't have to show the GCF up because we know it can include all the numbers, and then he has an n squared, he has an n, he doesn't. Since he doesn't have an n, they do not have a GCF, which means no GCF. Okay. Step 2, I'm going to write my trinomial form above it, that way we can see it. We have ax squared plus bx plus c. We need to find the factors of a and the factors of c. And I know I keep using that word factors, but if you're having trouble remembering what that means, factors are just numbers that multiply to. So as we make the factor list, factors are the numbers that multiply to a product. So, if I say we're going to find the factors of a and c, we're just going to find the factors that multiply to these two numbers. So, our first one's my very favorite. A is 1. And the only factors that can multiply to 1 are 1 times 1. Now, for our c, it's a positive 42. So, positive 42. And now our factors of 42. So, we always start with 1. So, 1 times 42 is 42. Then we do 42 divided by 2, and that gives us 21. So 2 times 21 is 42. 3 times 14 gives us 42. Once again, we're just dividing. So if you're not sure, it's good. 42 divided by 1, 42 divided by 2, 42 divided by 3. 42 cannot be divided by 4. 42 cannot be divided by 5. But 42 can be divided by 6. 6 going to 42 7 times. And then the next number we would try to be 7, but I already have it, so we're good. We can stop there. Alright, now step 3 is where we set up our answer, so you get 2 parentheses. And now we take our factors, sorry about that, we take our factors of a, which are 1, so 1 and 1. Because it has an n squared with it, we have to remember that means there's two n's there, so n and n. So I get a 1n to be my first term, and I get a 1n to be my first term in my second parenthesis, and we're good. Now, we need to find factors of c to make sure we find the ones that add to b. If you remember, we mentioned that back here in our notes. We drew like little lines under them. Make sure the outside and the inside can add to b. So we can go ahead and kind of do this. Now, our sign rules also come into play here because we're multiplying to a positive 42. So it's a positive 42. So if I add these and do 1 plus 42, I'm going to get 43. That's a positive number. If you look over here, my b is a negative number. It's a negative 13. So not only is that not going to work, but my signs are wrong. So to multiply to a positive number, they have to be the same sign. So they either both have to be positive, or they both have to be positive, or they both have to be negative. So I'm going to try negative and negative. So negative 1 plus a negative 42 is a negative 43. So once again, go through here, put negative symbols on everybody because all the signs have to be the same. So now we know negative 2 times a negative 21 is a positive 42. So we see what they add up to. Negative 2 plus negative 21 is going to give us a negative 23, so that's not going to work. It's not our negative 13. Alright, negative 3 plus a negative 14 gives us a negative 17. We're getting closer, but remember, I need that negative 13. And now, negative 6 plus a negative 7 gives us a negative 13, so that one works. So we're going to use our factors of negative 6 in our first parenthesis, and our factors of negative 7 in our second. And we're good. Now, to make sure we check, we have to multiply the outside and the inside, multiply the o's. So 1n times negative 7 is negative 7n. Negative 6 times 1n is negative 6n. Add these two together, so negative 6n plus a negative 7n gives me negative 13n, which is what we wanted, and we're set. Very good. I'm going to box this in. Alrighty. Now, second example. We have p squared plus 2p minus 35. Step 1, check them all for GCF, and because he's a 1, we don't have to have a GCF amongst the coefficients. Step 2, look at your variables. He has a p, he has a p, he does not, so no GCF. Step 2, we're going to find our factors that multiply to a, and to find our factors that multiply to c. So our a is 1, our c is a negative 35, and now we set up our table. We have our a, which is 1, and the beautiful part about 1, the only thing that multiplies to 1 is 1 times 1, and then our c, which is going to be a negative 35 this time. And now negative 35's factors. So 1 can go into a negative 35 times. 2 cannot go into 35. 3 cannot go into 35. 4 cannot go into 35, but 5 can. 5 can go into a negative 35 negative 7 times. So we're good. That's as far as the factors go for negative 35. We set up our two parentheses. We grab our factors of a, which are going to be 1. And remember, it has a p there, so p squared means I have to take a 1p. And then my other factor is 1, and it still has a p, so 1p. And now we have to find our factors here that will allow us to add to b. So we can which is going to be our positive 2. So we can kind of look through here and kind of see which ones are going to be too big. So 1 plus negative 35 is going to be a negative 34. That's too big. And also, if you notice, it gave me a negative 34. When we need the bigger number here to be positive because our 2 is positive. So I'm going to have to say that's a positive 35, and that's a negative 1 to make it positive 34. So negative 1 plus 35. So we kind of had to fix the signs there to make sure it went to a positive. Same way here, if I do 5 plus a negative 7, I'm going to get a negative 2. And I want a positive 2. So those numbers are right, because I got the right number of 2, but my sign's wrong. So I need to come through here and get rid of my negative there, my negative on my 7, and say it needs to be negative 5 times 7. So negative 5 times 7 is negative 35, and negative 5 plus 7 is going to give me positive 2. So these are the numbers that work. So my first factor of C that works is a -5. And my second factor was a +7, +7 there. So +7. And now, before we can say we're finished, we got to check it and make sure it works. 1p times 7 is 7p. -5 times 1p is -5p. Add them together, -5p plus 7p is 2p. And we check. We got the right factors. So this is our final answer to factoring trinomials. We have 2n cubed minus 34n squared plus 140n. So very first thing we're going to do is check for GCF. And because my smallest number now is a 2 instead of a 1, we're going to have to pay very close attention to that because these numbers are all even. We got 34 that's an even number, 140 that's an even number. So I can have a GCF of 2 because that's my smallest coefficient. And 2 can go into all even numbers. Somehow I got an extra line there. I don't know how that happened. There we go. And since 2 is our smallest coefficient here, we check it. We know 2 can go into 34 evenly, and 2 can go into 140 evenly because they're all even numbers. So this guy does have a GCF, and it has a GCF of 2 because that's my smallest coefficient here. And it can go into all these coefficients evenly. Now, we have an n cubed, an n squared, and an n. So amongst those variables, we take out the one with the smallest exponent, so that'll just be n and n. So divide everybody here by 2n. So 2 divided by 2 is going to be 1. You can show it if you want to. I know sometimes we do, sometimes we don't need to. And then n cubed minus, and if you remember we subtract that exponent of n to the first, so 3 minus the 1 is n squared. -34 divided by 2 is -17. N squared minus n to the first would give us just n, and 140 divided by 2 is +70. And we're good. We've successfully taken out our GCF. Now if you look inside this parenthesis, it now has 3 terms, 1, 2, 3. Which means it's a trinomial, so it looks like your ax squared plus bx plus c. If you notice, the first variable is always squared, the second variable isn't, and there's no variable on the last guy. So now we're going to have to find the numbers that multiply to a, and find the numbers that will multiply to c. So our a is 1, and the factors of 1 are 1 times 1. C is 70, and the factors of 70 are 1 and 70. 2, 35. 3 cannot go into 70 evenly. 4 cannot go into 70 evenly. 5 can. 5 can go into 70 14 times. 6 can't go into 70. 7 can. 7 go into 70 10 times. 8 cannot go into 70. 9 cannot go into 70. And the next one will try to be 10, and I already have it. So we're set. Got all of our factors. So now, next step. And here's a really important one, where this one had a GCF. This GCF here in front has to drop down to n. And then we write our answer with 2 parentheses for 2 terms each, so 2 binomials. And we put our factors of a. So the factors of a are 1. We have to take the n. So 1n. And my other factor is 1, so 1n. So we got our factors of our first term here. And now we move on to c. And remember, this is where we need to add them to b. So my b is a -17. So we need to add to b. So 1 plus 70 gives you 71. That's not going to work. For 1, it's positive. 2, it's a really big number. And if you notice here, we need it to be negative. So since we are multiplying to a +70, the signs need to be the same, which means they both need to be positive or they both need to be negative. So -1 times a -70, times a -70 gives us a +70. Then -1 plus a -70 gives us a -71. Still way too big. But we now know everybody here needs to be negatives, because a negative times a negative gives us the positive. So we got the factors right, now we have the signs right. So -2 plus a -35 is -37. That's too big. -5 plus a -14 gives us a -19, closer, but still not right. And then -7 plus a -10 will give us our -17. So negative 7 times negative 10 is positive 70, and negative 7 plus negative 10 is negative 17. So it works out both ways there. So my first factor of c that works is negative 7, and my second factor of c that works is negative 10. And we're good. Last thing to do is to check it, make sure we got it right. So 1 times negative 10 is negative 10n. Negative 7 times 1n is negative 7n. Negative 7n plus negative 10n is a negative 17n. And that's what we wanted, negative 17n. So it checks. There we go. Final answer.